Hi guys, my name is Melissa, and in today's video we're going to talk about constellation puzzles. And so constellation puzzles basically use fractions, including improper fractions where the numerator is bigger than a denominator, as well as mixed numbers. And so for constellation puzzles, we're going to have equivalent expressions, and so we're going to match the equivalent expressions together and create a constellation. Before we go into mixed numbers, we want to talk about improper fractions and mixed numbers. So improper fractions are in the form of a over b, and so it's going to be like 27 over 6. So the numerator is bigger than the denominator usually for improper fractions. Now as for mixed numbers, we have a whole number and then we have our fraction. And our fraction is usually like where the denominator is larger. So the fraction is not yet a whole number. It's not greater than 1, but we have a whole number in front. So what the mixed number tells us, so as the name states, it's a mixed number. It's a mix of a whole number plus a fraction. And so what the mixed number tells us is that it has however many number of whole numbers it has. So I know that sounds confusing, so I'll just write down an example. So for example, if we have 2 and 3 over 4, this indicates that it has 2 wholes. And we know that one whole is 4 over 4 because 4 over 4 is 1. So that means we have 2 of 4 over 4, and we have a 3 over 4. And so that is going to translate to 8 over 4 plus 3 over 4, which is going to be 11 over 4. And so an easy way to convert a mixed number into an improper fraction, because sometimes it's easier to work with improper fractions when we add or subtract, is you multiply. So now that you've understood how to convert, what you do is you leave the denominator. So you leave the denominator, and then you multiply the whole number in the denominator. So that's going to be 2 times 4, which is 8. And then you add the original numerator, and so that's going to give you your improper fraction. And so now then what we should also learn about vice versa and what we should do when we convert from improper fractions to mixed numbers. So for example, if we have an improper fraction like 27 over 6, you first want to find out you first want to figure out a multiple of the denominator that is closest to the numerator but is still smaller than the numerator. So for example, a multiple of 6 that is closest to 27 and is smaller than 27 is going to be 24. So 6 times 4 is 24. And that's going to be the smallest and closest to 27. Then we know that we still have 3 over 6 missing because 27 over 6 minus 24 over 6 is going to be 3 over 6. And so that is going to be, so this combination gives us 27 over 6. But then we know that 24 over 6 is 4. So that is going to be our whole number. And then we simplify this fraction into 1/2, and that's going to be the fraction portion of our mixed number. And so, yeah, if we try the trick to convert mixed number into improper fraction, leave the denominator, multiply, and add. So it's going to be 9/2. And so some of you guys might wonder, oh, 9/2 is not 27/6, but that is due to simplification. We multiplied by 3 for the denominator, also multiplied by 3 for the numerator, so those were equivalent expressions. And so that is how we change from improper fractions to mixed numbers, and from mixed numbers to improper fractions. Now that we're going to talk about addition and subtraction for fractions, we're going to go over some rules for fractions. And so if we have the same denominator and we want to add, then we keep the denominator because it's the same, so it's a common denominator. We don't need to look for a common denominator because it's already the same. And so we're just going to add the numerators together with one common denominator. Also the same for when we subtract. If there's a common denominator, we keep that denominator and only work with the numerators. Now this is when it's just a regular fraction, like written in the form a/b, whether it's improper or proper. But then when we have mixed numbers, like a whole number and then a fraction, how do we add or how do we subtract? And so there's an easy and basic way of adding and subtracting mixed numbers, and in the lesson we're going to learn about more ways to subtract and add. But what I think is the easiest way is you separate the whole numbers and fractions. So for example, if one mixed number is 2 and 3/4, and we want to add it to 6 and 1/4. What I mean is you want to separate the whole numbers. So we're going to consider 2 and 6 separately as 2 1/4 and 3/4. And so 6 and 2 are whole numbers, so we're going to add those together. So we have 8 for whole numbers. Then for fractions, we have 3/4 and 1/4, and when we add them together, it's going to be 1. And then we add the sum of the whole number and add the sum of the fractions. And so we get our final sum. Now, another example is when the fractions don't really come out to be a whole number. So it can be like 9 and 7/15 plus 2 and 2/15. Now again, we're going to think of the whole number separately. So 9 plus 2 is 11, and when we think about the fractions, it's 7/15 plus 2/15, which is 9/15. We can simplify this by dividing both the numerator and the denominator by 3. So we can simplify it into 3/5. And so we're going to combine 11 and 3/5. And we can write that out as 11 and 3/5. Now just for clarification, we can write this as an improper fraction as well, based on what we learned last class. So keep the denominator, multiply the whole number in denominator, which is 55, and then add the original numerator. And so the way to write that as the improper fraction is 58 over 5. And now let's look at some more problems that involve addition and subtraction of mixed numbers and fractions. And so for example, I'll start by solving 127 to kind of explain to you how this would look like. So for example, we have the mixed number 1 and 8 over 5. And so 1 and 8 over 5, we learned in the previous video that to convert a mixed number, we multiply the denominator by the whole number. So that's going to be 1 times 5. So we leave the denominator as it is, and then we do whole number times denominator, so that's going to be 5, plus whatever is in the numerator, so 8. And that's going to be our fraction written in improper form. So this mixed number is basically equivalent with the improper fraction 13 over 5. And we have 13 over 5 here, so we're going to connect these two dots. And then we can also, if we look at this mixed number, 1 and 8 over 5, actually it's not a correct type of mixed number because the 8 over 5 itself is an improper fraction. So if we want to simplify to the fullest, 8 over 5 is going to be 5 over 5 plus 3 over 5, which is 1 plus 3 over 5. And so in total, that's going to be 2 and 3/5. And we have 2 and 3/5 here. And so we're going to connect these dots. And so these three are going to be equivalent expressions. Then we're going to look for other equivalent expressions. And if we have 16 over 5, we're going to try to make it into a mixed number. And so we know that 16 over 5 is 15 over 5 plus 1 over 5, which is 3 plus 1 over 5, so it's going to be 3/1/5. And we have it right here, so we're going to connect the dots. And then another way that we can write 3 1/5 is we can write it this way. So again, this is a mixed number, but the fraction involved is improper. So 2 6/5 can be written as 2 plus 5 over 5 plus 1 over 5, which is going to be 2 plus 1 plus 1/5. So it's going to be 3 1/5. So that's also an equivalent expression. So we're going to connect the dots as well. And so automatically we know that these three dots must be connected, but we're still going to check just in case. So 14 over 5 is 10 over 5 plus 4 over 5, which is 2 4/5, which we have right here. And that can, and 1 and 9 over 5 is going to be 1 plus 5 over 5 plus 4 over 5. So essentially that's also 2 4/5. So that is what we call constellation puzzles. So we're matching equivalent expressions and connecting the dots to create a kind of like a constellation. So now we're going to look at problem 128. So I want you guys to try solving problem 128 on your own. So it's solved by looking for equivalent expressions and then connecting the dots to create constellations. And then I'll give you guys about 3 minutes to do that, and then you can come back to the video after 3 minutes. So I've set 3 minutes in the video, but if you need more time, you can definitely pause the video, and then I'll be going over the solutions and showing you what the constellation should look like. And so we have 19 over 8, and 19 over 8, if we simplify it into a mixed number, it's going to be 16 over 8 plus 3 over 8, and that is going to be 2 plus 3 over 8, which is 2 and 3/8. And so we have 2 and 3/8 here, so we're going to connect the dot. And so we're also going to find another mixed number. And so it's either 1 and 15 over 8 or 1 and 13 over 8. So to check, 1 and 15 over 8 is going to be 1 plus 8 over 8 plus 7 over 8. So that is larger. But if we look at 1 and 13 over 8, that's going to be 1 plus 8 over 8 plus 5 over 8. And so that is going to be that is going to be 2 and 5 over 8, so that's also big. So we need to find a different possible one. And another possible one could be 1 and 11 over 8. So 1 and 11 over 8 would be 1 plus 8 over 8 plus 3 over 8, which is 2 plus 3 over 8. So it's 2 and 3/8. So this is an equivalent expression, so we're going to connect the dots. Now, but it's also important to see how you connect the dots. So if you look here, if we connect the dots like this, as we just did, then it's going to be impossible or really hard for us to connect these dots. So instead of connecting it like this, we can connect it like this. And then for the remaining numbers, we're going to look for equivalent expressions. So 23 over 8 is going to be 16 over 8 plus 7 over 8, so it's 2 7/8. So these two are equivalent expressions. And 1 and 15 over 8 is also 1 plus 8 over 8 plus 7 over 8. So that is basically 2 and 7 over 8. So that's also an equivalent expression. So we're going to connect the dots. And so eventually the other 3 dots are going to be connected. Like so. Now we're going to look at problem 129. And so we have 35 over 9, which is 27 over 9 plus 8 over 9. So it's 3 plus 8 over 9. So it's 3 8/9. And we have that here. So we're going to connect the dots. But then we're also going to look for the other equivalent expression. So we're just going to circle it for now. And that would be 2 and 17 over 9. Because 2 and 17 over 9 is going to be 2 plus 9 over 9 plus 8 over 9, which is going to be 3 8/9. And so since it's like this, we're going to connect it like this so that we can connect other dots as well. So we're going to connect it like so. Then we're going to look for another combination of 3 numbers that are equivalent. So we have 29 over 9, which is 27 over 9 plus 2 over 9, which is 3 and 2/9. So these two are equivalent expressions. Now we need to find one more equivalent expression to those two. And it can probably be 2 and 11 over 9. Since 2 and 11 over 9 is 2 plus 9 over 9 plus 2 over 9, so it's going to be 3 plus 2 over 9, so it's 3 and 2/9. And so the remaining 3 numbers eventually will be equivalent and will be connected to each other in a constellation-like shape. Now we have problem 130 left. And so we have 37 over 7, an improper fraction, which can be written as a mixed number. So this can be written as 35 over 7 plus 2 over 7. So that's going to be 5 and 2/7. So these two are going to be equivalent. So we're going to connect those 2 dots. And then 4 and 9 over 7 is also equivalent because 4 and 9 over 7 is 4 plus 7 over 7 plus 2 over 7, so it's 5 and 2/7. Then we're going to look for another combination of 3 equivalent expressions. So we have 39 over 7, and so that is going to be 35 over 7 plus 4 over 7, which is 5 and 4/7. So we're going to connect these 2 dots together. And we know that 4 and 11 over 7 is also an equivalent expression. because that is 4 plus 7 over 7 plus 4 over 7. So it's 5 and 4/7. And so the remaining three numbers are equivalent expressions, and we're going to connect the dots for these three as well. Now we're going to learn about subtracting mixed numbers. And so for subtracting mixed numbers, we have 7 and 4 over 5 minus 3 and 1 over 5. And so over there, so in this question, we're first going to subtract the whole numbers, just like we do for addition. And so we're going to do 7 minus 3, which is 4. And then we're going to do 4 over 5 minus 1 over 5, which is going to be 3 over 5. And so our result is going to be 4 and 3/5. Now we're going to do the same thing for the practice problems. And so we're going to subtract the whole numbers first. 8 minus 2 is 6. Then the fraction, so 3 over 7 minus 1 over 7 is 2 over 7. And so we add those two together, which is going to be 6 and 2/7. For our next problem, we're going to subtract the whole numbers together. Then we're going to subtract the fractions. And so it's going to be 4 and 4 over 11. Then we have the next problem. So again, we're going to subtract the whole numbers first, and then subtract the fraction, which is 0. So 2 is going to be our answer. Then we're going to do whole number subtraction first. Then we're going to subtract the fractions. So it's going to be 6 over 10, which can be simplified into 3 over 5. So our answer is going to be 5 and 3 over 5. And then for 135, we're going to subtract the whole number first. Then we're going to do fraction subtraction. So it's going to be 3 and 1/5. Now for problem 136, again, subtract whole number first, and then subtract the fraction. And we can simplify the fraction into 3 over 5. So the answer is going to be 2 and 3/5. And I believe that was the same page, so we're going to skip this page. Sorry for the confusion. So we're going to skip this page since it was the same page. And then we're going to move on to our next page. So it says subtract 6 and 4 over 7 minus 2 and 6 over 7. So we're first going to subtract the whole numbers, so it's going to give us 4. But when we're trying to subtract the fraction, we can see that the numbers that we're trying to subtract is larger than the number that we're subtracting from. And so that is going to get us -2 over 7. And so when we add the whole number and fraction together, it's going to be 4 plus negative 2 over 7. So it's going to be 4 minus 2 over 7. And 4 can be written as 28 over 7. So we can write this as 26 over 7. And 26 over 7 can be written as a mixed number of 21 over 7 plus 5 over 7. So it's going to be 3 and 5 over 7. Now, but that involved changing it to improper fraction and then changing it to mixed number back again. So instead of doing that, we can regroup 6 and 4 over 7. So we can take 1 away from that and add it to the 4 over 7. So what we can do is we can make the 6 and 4 over 7 into 5 and 11 over 7. Now when we have that, we can do 5 minus 2 equals 3, and 11 over 7 minus 6 over 7, which is 5 over 7, so that gives us 3 and 5/7. And so we're going to do the same thing for the practice problems. And so since the one we're subtracting is larger, we're going to rearrange 10 and 4/9 into 9 and 13 over 9. And so we subtract the whole number first, then subtract the fraction. So that's going to give us 3 and 8/9. And then we're going to look at our next problem. And so I want you guys to try solving problem 138 on your own, using the same concept of grouping the whole numbers together and the fractions together. And so I'll give you guys about 1 to 2 minutes, and then we're going to go over the explanation and solution together. Again, we're going to rearrange 4 and 1/3 into 3 and 4/3. Again, subtract whole number first, then subtract the fraction. So our answer is going to be 1 and 2/3. Next, we're going to rearrange 7 and 5 over 11 into 6 and 16 over 11. And so 6 minus 3, only for the whole numbers, is 3. Subtraction for the fraction is going to be 7 over 11. So our answer is going to be 3 and 7 over 11. And then again, we're going to do the same thing. We're going to rearrange 8 and 1/4 into 7 and 5/4. And so when we subtract the whole number, we get 4, and when we subtract the fraction, we get 1/2. It was 2/4, so when we simplify, it's 1/2. So our answer is going to be 4 and 1/2. Then for problem 141, we're going to rearrange 8 and 5/14 into 7 and 19/14. And so subtract the whole number, then subtract the fractions, and then simplify. So we get 1 4/7. Now this is our final question of the video. So I want you guys to give this question a go since it's our last problem. And so I'll give you guys about 1 minute to solve this problem, and then we'll go over the solution together at the end. So we're going to rearrange 12 and 1/9 into 11 and 10/9. And so for the whole number, it's going to be 11 minus 5, which is 6. For the fraction, it's going to be 3/9, which is 1/3. And so our answer is going to be 6 and 1/3. And yeah, that was it for today's video. And I'll see you guys on the next video. Thank you.